Before we begin, a quick disclaimer. The information in this presentation is for educational and informational purposes only. I am not a financial advisor or a career coach. The salary figures mentioned are based on publicly available data for the United States market and can vary significantly based on your location, experience, and negotiation skills. This video does not guarantee employment or any specific income level. Please do your own thorough research before making any career decisions. What if I told you there's a six-figure job market in the United States that's so desperate for people, it's practically begging you to apply? A field where you don't need a 4-year computer science degree from a fancy university, you don't need to be a math genius, and you definitely don't need to have been coding since you were 12. And the best part? This isn't some flash-in-the-pan trend. This is the bedrock of our entire digital world, and it's creating a tidal wave of high-paying jobs that most people don't even know exist. If you've ever felt stuck in your career, underpaid, or worried that your job might not be around in 5 years, then you need to listen very, very closely. Because what I'm about to share with you isn't just a list of jobs. It's a roadmap, a step-by-step guide to breaking into one of the most lucrative and future-proof industries on the planet, cloud computing. Over the next few minutes, I am going to reveal the top 5 most in-demand cloud computing jobs in the USA right now. But we're not just going to skim the surface. For each role, I'm going to break down exactly what these people actually do every day in plain English. I'll show you the real-world salary ranges you can expect, from the day you start to the day you become a senior expert. And most importantly, I'm going to lay out the specific skills and certifications you need to get your foot in the door, and how you can start learning them today, even if your current job has nothing to do with tech. This is the blueprint that can take you from where you are now to a high-demand, high-respect, six-figure career faster than you ever thought possible. So what even is the cloud? Forget the jargon. It's simple. Every time you stream a movie on Netflix, check your email on Gmail, or post a photo to Instagram, that data isn't living on your phone or your laptop. It's living in a massive, ultra-powerful computer in a giant warehouse owned by a company like Amazon, Google, or Microsoft. That's the cloud. It's just someone else's computer. And right now, virtually every company on Earth, from tiny startups to Fortune 500 giants, is racing to move their operations onto these computers. Why? Because it's cheaper, faster, and more secure. This massive migration has created an explosion of new jobs, and there simply aren't enough qualified people in the United States to fill them. This isn't a skills gap. It's a skills canyon, and that's where you come in. We're going to count down from number 5 to the single most valuable cloud job you can target today. And we're starting with the ultimate entry point, the role that serves as the main gateway into this entire world. Coming in at number 5 on our list is the cloud support engineer, sometimes called a cloud technician or cloud support associate. Now, don't let the word support fool you. This is not your average IT help desk job where you're telling someone to turn their computer off and on again. Think of a cloud support engineer as a first responder for the internet. They are the highly trained problem solvers on the front lines, helping businesses that run on platforms like Amazon Web Services, Microsoft Azure, or Google Cloud. When a company's website goes down, when their application is running slow, when they can't access their data, the cloud support engineer is the 911 call they make. They are the detectives who parachute in, diagnose the problem, and fix it. So what does a day in the life look like? It's a mix of technical troubleshooting and customer communication. You might start your morning looking at a ticket from an e-commerce company whose website crashed during a huge sale. You dive into their cloud environment, looking at logs, checking network configurations, analyzing performance metrics to figure out what went wrong. You're a puzzle solver. Later, you might get on a call with a software developer who is having trouble deploying a new feature and guide them through the process. You are part tech wizard, part teacher, part consultant. This role is perfect for people who love solving problems, enjoy helping others, and want to learn by doing. Why is this such a fantastic starting point? Because you are paid to learn. In this role, you will be exposed to a wider variety of cloud services and real-world problems than in almost any other position. You'll see firsthand how hundreds of different companies use the cloud, what breaks, and how to fix it. This practical, hands-on experience is pure gold, and it builds an incredible foundation for your entire career. You're not just reading about the cloud in a textbook, you're living inside it. Now let's talk money. What can you expect to earn as a cloud support engineer in the US? Entry-level positions, often called associate cloud support engineers, typically start in the $60,000 to $85,000 range, depending on your location. That's a phenomenal starting salary for a role that is often accessible without a 4-year degree. As you gain experience and specialize, moving into a mid-level or Tier 2 support role, you can expect that to climb to between $85,000 and $120,000. And for senior support engineers or team leads who handle the most complex, high-stakes problems, salaries can easily push past $130,000 and beyond. So, how do you become one? This is the best part. The barrier to entry is lower than you think. First, you need foundational knowledge. This is non-negotiable. The best way to prove you have it is with a foundational certification. For Amazon Web Services, that's the AWS Certified Cloud Practitioner. For Microsoft Azure, it's the AZ900, Azure Fundamentals. These certifications show hiring managers that you understand the basic language of the cloud, what it is, what services it offers, and the value it brings to a business. Next, you need to develop some core technical skills. You don't need to be an expert, but you need to be familiar with the basics of operating systems, especially Linux, which powers a huge portion of the cloud. You should also understand the fundamentals of computer networking, what an IP address is, what a DNS does. And crucially, you need to cultivate your problem-solving skills. The ability to look at a complex problem, break it down into smaller pieces, and work through it logically is the single most important trait of a great support engineer. Finally, don't underestimate soft skills. Your ability to communicate clearly, listen patiently, and manage a stressful situation with a calm, confident demeanor is what separates a good technician from a great one. This is why people from customer service, retail, or even teaching backgrounds can excel in this transition. They already have the empathy and communication skills hardwired. The career path from here is incredible. After a year or two as a cloud support engineer, you've built an arsenal of real-world experience. You can then pivot into a more specialized, higher-paying role. Enjoyed working with networks? You can become a cloud network specialist. Fascinated by security? You can move into a cloud security role. Love building and automating things? The next job on our list, the cloud administrator, is a natural and lucrative next step. The cloud support engineer is the launchpad, the boot camp that forges your skills under fire and prepares you for a massive career in the cloud. It's the perfect place to start, and that's why it's number 5 on our list. But the jobs only get more powerful, and the paychecks only get bigger from here. Let's move on to number 4. Coming in at number 4, we have the guardians of the digital galaxy, the sentinels standing watch on the virtual walls. We're talking about the cloud security engineer. Imagine this. A company spends millions, maybe even billions, building an incredible, innovative application on the cloud. It's their crown jewel. It holds all their customer data, their trade secrets, their financial records. Now imagine a single hacker in a dark room, thousands of miles away, finding one tiny crack in the armor, one unlocked digital door, and walking away with everything. The company's reputation is destroyed overnight. The stock plummets. Lawsuits pile up. It's a corporate apocalypse. That nightmare scenario is exactly what the cloud security engineer is paid to prevent. They are the modern-day knights, blacksmiths, and strategists of the digital realm, all rolled into one. Their entire job is to think like a hacker, to anticipate every possible attack, and to build a fortress so strong, so complex, that attackers simply give up and move on to an easier target. This isn't just about putting up a firewall and calling it a day. We're talking about designing and implementing a multi-layered defense strategy. They are masters of identity and access management, or IAM. Think of them as the ultimate bouncers for a VIP club. They decide exactly who gets in, what they're allowed to see, and what they're allowed to do. A sales rep can access customer data, but they can't delete the entire database. A developer can write code, but they can't push it into production without approval. The cloud security engineer builds these intricate rules to ensure that even if one account is compromised, the damage is contained. They live and breathe encryption, turning sensitive data into unreadable code both when it's sitting on a server and when it's flying across the internet. They conduct vulnerability assessments and penetration testing, which is basically a fancy way of saying they are paid to legally hack their own company to find weaknesses before the bad guys do. And the demand? It's off the charts. With every major data breach that hits the headlines, and there are new ones every week, executives and boards of directors are jolted awake, realizing that cybersecurity isn't an IT expense, it's a business survival strategy. They are throwing money at this problem because the cost of a breach is 100 times more than the salary of a good security team. So what does that mean for pay? According to the latest industry data, An experienced cloud security engineer in the United States can expect to earn anywhere from $120,000 to $185,000 a year. And for senior or principal-level engineers who are experts in areas like threat intelligence or incident response, that number can easily soar past $200,000, plus bonuses. To become a cloud security engineer, you need a unique blend of skills. You start with a solid foundation in IT and cybersecurity fundamentals. Certifications like CompTIA Security Plus are a great starting point. But then you must specialize in the cloud. You need to master the security tools of a specific platform, like AWS Security Hub, GuardDuty, or Microsoft's Azure Sentinel. Earning a certification like the AWS Certified Security Specialty or the Certified Cloud Security Professional, CCSP, is a massive signal to employers that you know your stuff. You're not just a security person, you're a cloud security expert. It's a role for the paranoid, the meticulous, and the eternally vigilant. But a fortress, no matter how secure, is useless if no one can get to it. What good is the world's most secure online store if the website takes 30 seconds to load? What good is a revolutionary streaming service if the video is constantly buffering? Securing the data is mission critical, but ensuring that data can travel at the speed of light is a completely different and equally vital challenge. This brings us to our number 3 most in-demand job, the cloud network engineer. If cloud security engineers are building the fortress, cloud network engineers are building the 12-lane, high-speed superhighways that connect that fortress to the entire world. They are the civil engineers of the digital age. Their job is to design, build, and maintain the complex web of virtual networks that allows data to flow seamlessly, reliably, and instantly between servers, applications, and end users. In the old days, networking meant dealing with physical routers, switches, and messy closets full of tangled cables. Today, in the cloud, all of that is virtualized. It's all software. But the complexity hasn't disappeared. It's just changed form. A cloud network engineer has to be a master of this virtual world. They design what are called virtual private clouds, or VPCs. Think of a VPC as your own private, securely isolated section of the public cloud. It's like having a dedicated, fenced-off estate inside a massive national park. The network engineer carves out this space and then designs everything inside it. The subnets, which are like different neighborhoods within your estate, the route tables, which are the GPS systems that tell data packets exactly how to get from one neighborhood to another, and the network access control lists, which are like neighborhood security guards that check IDs at the gate. But their most important job is ensuring performance and reliability. They are obsessed with 2 things: latency and bandwidth. Latency is the delay, how long it takes for a packet of data to get from point A to point B. Bandwidth is the capacity, how much data you can send at once. The cloud network engineer's goal is to minimize latency and maximize bandwidth. To do this, they use powerful tools like load balancers. Imagine a massive grocery store with 100 checkout lanes. A load balancer is the super-efficient manager at the front who directs every single shopper to the shortest, fastest-moving line. This prevents any one server from getting overwhelmed and ensures a smooth, fast experience for every user, even during a massive traffic spike like Black Friday. They also architect content delivery networks, or CDNs. A CDN is a genius concept. Instead of having your website's images and videos stored in one single location, say Virginia, a CDN places copies of that content in data centers all over the world: London, Tokyo, Sydney, you name it. So when a user in Australia visits your site, they get the data from the nearby Sydney server, not from halfway across the planet. The result is a dramatically faster experience. This is the magic that makes Netflix and YouTube work so flawlessly, no matter where you are. Every millisecond counts in the digital economy. Studies have shown that even a 1-second delay in page load time can cause a significant drop in sales for an e-commerce site. For high-frequency trading firms, a millisecond of latency can be the difference between making millions and losing millions. For online gaming, it's the difference between a win and a frustrating lag-filled loss. This is why companies are desperate to hire elite cloud network engineers. They don't just move data, they enable business. And they are paid handsomely for it. A skilled cloud network engineer in the US typically earns between $115,000 and $170,000. For those who specialize in complex, large-scale global networks or network automation, salaries well over the $180,000 mark are common. The path to this role starts with a deep understanding of traditional networking. Certifications like the Cisco CCNA are still incredibly valuable as a foundation. From there, you pivot to the cloud. You need to master the networking services of AWS, Azure, or Google Cloud, earning a certification like the AWS Certified Advanced Networking Specialty is considered a gold standard and will make your resume jump to the top of the pile. So we've built an impenetrable fortress with our cloud security engineer. We've constructed vast, lightning-fast superhighways with our cloud network engineer. The foundations are solid. The infrastructure is world-class. But what are we going to build on top of it? What about the skyscrapers, the power plants, and the automated factories that make up this digital city? Who actually designs and builds the core systems that run everything? That brings us to our number 2 spot. This role is for the master architects, the grand designers of the cloud. They don't just secure the perimeter or manage the traffic. They build the very engine that powers the entire enterprise. I'm talking about the cloud solutions architect. If a cloud engineer is the master mechanic keeping the engine running, the cloud architect is the Leonardo da Vinci who designed the engine in the first place. They are the visionaries, the strategic thinkers who look at a company's messy, complicated business problems and design an elegant, efficient, and powerful cloud infrastructure to solve them. Think about it. A company says, "We want to launch a new streaming service to compete with Netflix. It needs to handle millions of users, be secure against hackers, never go down, and not bankrupt us in the process." Who do they call? Not the engineer first. They call the architect. The cloud architect is the one who sits down with the CEO, the CFO, and the head of product and translates that business dream into a technical blueprint. They make the big decisions. Should we use Amazon Web Services, Microsoft Azure, or Google Cloud Platform? Or maybe a multi-cloud strategy? How do we structure the network for maximum security and performance? What kind of databases do we need? How do we design the system to automatically scale up during peak hours and scale down at 3 a.m. to save money? They have to think about everything: disaster recovery, data compliance, cost optimization, and future growth. They are playing a high-stakes game of three-dimensional chess with technology, business goals, and budget constraints. This role is exploding in demand for one simple reason: bad architecture is catastrophic. A poorly designed cloud system is like building a skyscraper on a foundation of sand. It might look fine at first, but it will be slow, insecure, insanely expensive, and will eventually collapse under pressure. Companies are realizing that hiring a brilliant architect up front saves them tens of millions of dollars and years of headaches down the line. They are the ultimate insurance policy against technological disaster. They're also the key to unlocking innovation. When a new technology like serverless computing or a powerful AI service comes out, it's the architect who figures out how to weave it into the company's existing systems to create a competitive advantage. So, what does it take to become this grand designer? First, you need deep, hands-on technical expertise. You can't design a system you don't understand how to build. Most architects come from senior roles in cloud engineering, software development, or network administration. They've spent years in the trenches. They know the AWS, Azure, or GCP console like the back of their hand. They understand the subtle differences between various database services, the nuances of virtual private clouds, and the intricacies of identity and access management. But here's the critical part that separates a good engineer from a great architect: business acumen. You have to speak the language of the boardroom. You need to understand concepts like total cost of ownership and return on investment. You have to be able to explain a complex technical trade-off to a non-technical executive in a way that they can understand and make a multi-million-dollar decision based on your recommendation. This is why communication, presentation, and persuasion skills are just as important as your technical chops. Now for the numbers. Because this role blends high-level technical expertise with strategic business impact, the compensation is astronomical. A cloud solutions architect in the United States can expect a salary ranging from $150,000 to well over $250,000 per year. And that's just the base. Senior and principal architects at major tech companies, the ones designing systems at a global scale, are easily clearing $300,000, $400,000, even $500,000 or more with stock and bonuses. It's a role that puts you on a direct path to executive leadership, like a director of cloud strategy or even a chief technology officer. The path to becoming an architect is a marathon, not a sprint. There's really no such thing as a junior architect. You have to earn it. The journey often starts with getting a foundational certification like the AWS Certified Solutions Architect Associate. This isn't just about passing a test. It's a structured way to learn the breadth of services and, most importantly, the AWS well-architected framework, the very principles of good cloud design. From there you build. You volunteer for design-related tasks on your team. You study for the professional-level certifications. You learn to think about cost, security, and reliability for every single component you deploy. You start asking why instead of just how. Why this database instead of that one? Why this network topology? That curiosity, that drive to understand the big picture, is the heart of a true architect. The cloud architect designs the blueprint for the entire city. The security engineer builds the walls and defends it. The cloud engineer keeps the power grid and the water flowing. So, what could possibly be more in demand than the master planner? That brings us to our #1 most in-demand cloud computing job in the USA. This role is different. It's not just about designing the city or defending it or maintaining it. This role is about building the automated, self-healing factory that can construct, deploy, and update the entire city in minutes with the push of a button. They are the masters of speed, scale, and stability. They take the architect's beautiful blueprint and merge it with the developer's brilliant code, creating a seamless, high-velocity pipeline that powers modern technology as we know it. They are the force multipliers, the ones who empower a small team of developers to do the work of 1,000. And that brings us to our #3 most in-demand cloud job in the United States right now, the DevOps engineer. This isn't just a job title. It's a philosophy, a culture, and the absolute engine room of modern software development. To understand why these professionals are paid so handsomely, often starting well over $100,000 and soaring past $200,000 for senior talent, you first have to understand the world before DevOps. Imagine two kingdoms, separated by a giant, impenetrable wall. On one side, you have the kingdom of development. Here, brilliant developers are like master artisans crafting beautiful, complex code. They build amazing new features, fix bugs, and pour their creativity into the product. Their world is all about speed, innovation, and change. Once they're done building something, their job is to get it ready for the world. So they bundle up their code and, metaphorically, they throw it over the wall. On the other side of that wall is the kingdom of operations. These are the guardians of stability. Their job is to keep the company's servers running, stable, and secure. They hate surprises. They hate change. Their motto is, if it ain't broke, don't fix it. So when this mysterious bundle of new code comes flying over the wall from the developers, their first reaction is panic. They don't know how it was built, what it needs to run, or how it might break their perfectly stable environment. What happens next is chaos. The developers yell, "It worked on my machine." The operations team yells back, "Well, your machine isn't the production server." Releases that should take hours end up taking weeks. Blame gets passed back and forth. Customers get angry. The business loses money. This wall of confusion was the single biggest bottleneck in the tech industry for decades. And then the DevOps engineer arrived. They didn't just climb the wall. They took a sledgehammer to it and smashed it into dust. A DevOps engineer lives in the space between development and operations, and their primary mission is to merge these two worlds. They do this through 3 core pillars: automation, infrastructure, and culture. Let's start with automation, specifically something called the CI/CD pipeline. That stands for continuous integration and continuous deployment. Forget the jargon for a second. Think of it like a hyper-efficient, fully automated factory assembly line for software. When a developer writes a new piece of code, they don't just throw it over the wall anymore. They commit it to a central repository, and this action instantly triggers the CI/CD pipeline. The first machine on the assembly line grabs the code and runs a battery of automated tests to check for obvious errors. If it passes, it moves to the next station where it's combined or integrated with the main code base. Then more tests are run. Security scans. Performance checks. The code is packaged up into a neat, ready-to-go bundle. Finally, if all the lights are green, the pipeline can automatically deploy that new code to the live servers, making it available to millions of users, sometimes within minutes of the developer finishing their work. The DevOps engineer is the architect of this entire factory. They build it, they maintain it, and they optimize it. They use tools like Jenkins, GitLab CI, and Circle CI to create a seamless flow from a developer's keyboard to the customer screen. This is how companies like Netflix and Amazon can update their applications hundreds, or even thousands of times per day, while their competitors are stuck in the old world, struggling to release once every 6 months. The second pillar is infrastructure as code, or IAC. This is a game changer. In the old days, if you needed a new server, the operations team would have to manually log into a console, click through dozens of menus, configure networking, set up security rules. It was slow, tedious, and prone to human error. If you needed 10 servers, you had to do it 10 times. And what if the person who set it up leaves the company? Nobody knows exactly how it was configured. A DevOps engineer using IAC says, "That's insane. I'm going to write code to define my infrastructure." Using tools like Terraform or AWS CloudFormation, they write a blueprint. A simple text file that says, "I need 5 web servers of this size with this operating system, connected to this database, behind this load balancer, with these specific security rules." And here's the magic. They can run that code, and the cloud provider, AWS, Azure, or Google Cloud, will automatically build that exact environment in minutes. Need to build the same environment for testing? Just run the code again. Need to deploy in a different region on the other side of the world? Run the code again. Need to tear it all down to save money? One command and it's gone. The infrastructure becomes as manageable, version-controlled, and repeatable as the application code itself. It's the ultimate form of consistency and scalability. The third, and perhaps most critical piece of the puzzle, is containerization. Specifically, Docker and Kubernetes. This is the technology that truly glues everything together. Remember that "it worked on my machine" problem? Docker solves that forever. Docker allows a developer to package their application, along with all of its dependencies, every library, every configuration file, everything it needs to run, into a single lightweight portable box called a container. This container will run identically no matter where you put it, on a developer's laptop, on a testing server, or on a massive production server in the cloud. Just works. But what happens when your application becomes wildly popular, and you need to run not just one container, but 10,000 of them, all working together across hundreds of servers? That's where Kubernetes comes in. Kubernetes is the master orchestrator. It's like the conductor of a massive symphony orchestra of containers. It tells each container where to run, how to talk to other containers, and what to do if one of them fails. If a server goes down, Kubernetes automatically moves its containers to a healthy server, without any human intervention. If traffic suddenly spikes on your website, Kubernetes can automatically scale up, launching hundreds of new containers in seconds to handle the load, and then scale them back down when traffic subsides to save money. A DevOps engineer who has mastered Docker and Kubernetes is, without exaggeration, one of the most valuable and sought-after professionals in the entire tech industry today. They are the ones who build the resilient, self-healing, and infinitely scalable systems that power the modern internet. So, what does it take to become one? The path isn't easy, but it is straightforward. You start with a rock-solid foundation in Linux and networking. You have to understand how the underlying systems work. Then you pick a major cloud provider like AWS and learn its core services inside and out. You must learn to script. Python is the undisputed king here, used for automating everything. Then you dive headfirst into the Holy Trinity. Learn Docker to containerize applications, learn Terraform to build your infrastructure as code, and then tackle the beast, Kubernetes. Build projects. Automate the deployment of a personal website. Create a full CI/CD pipeline for a simple application. Prove you can do the work. Because the demand is relentless. Every company, from tiny startups to Fortune 500 giants, is undergoing a digital transformation, and they know that speed and reliability are paramount. DevOps is the answer. The average salary for a DevOps engineer in the US hovers around $125,000, but it's common to see mid-level roles at $150,000 and senior or specialist roles easily clearing the $200,000 mark, especially in major tech hubs. The reason is simple. A single great DevOps engineer can amplify the productivity of an entire development organization, directly impacting the company's bottom line. They are the ultimate force multiplier. They are the ones who build the highways that allow developers to ship code at the speed of thought. They are the architects of the resilient automated systems that we all rely on every single day. Whether we're streaming a movie, ordering a ride, or banking online, it's a challenging, high-impact role that sits at the very epicenter of modern technology. But what if you love building the infrastructure, but you're less interested in the developer pipeline and more fascinated by the raw, underlying architecture of the cloud itself? What if you want to be the one who designs the entire city, not just the highways that run through it? Well, that's where our number 2 job comes in. This role takes the principles of cloud computing to a whole new level, focusing on the grand design of it all. And that brings us to the number 2 most in-demand cloud job in the USA right now, the cloud architect. If the cloud network engineer is the master of the digital highways, the cloud architect is the master city planner, the lead designer, the visionary who conceives of the entire metropolis from the ground up. They don't just ask, how do we build this road? They ask, where should the city even be built? What kind of city will it be? A sprawling commercial hub? A high-density residential zone? A secure government compound? A cloud architect is the ultimate translator. They stand with one foot in the world of high-level business strategy and the other in the world of deep, complex technology. Their job is to listen to the CEO's vision for the company's future. A vision that might be as simple as we need to grow by 300% in the next 2 years, and translate that into a concrete, technical blueprint for a cloud environment that can make it happen. Let's make this real. Imagine a new startup, let's call them Streamflix, wants to launch the next big video streaming service. They go to a cloud architect. The architect doesn't immediately start spinning up servers. First, they listen. They ask the critical questions. Who are your users? How many do you expect on day one? How many in a year? Are they all in the US or global? What's your content delivery strategy? How do you handle massive, unpredictable spikes in traffic? Like when a new hit show drops. What's your budget? What are your security and compliance requirements? Based on these answers, they begin to design the system. They are the ones who decide, okay, for this we're going with Amazon Web Services. We'll use their S3 service for storing the raw video files because it's infinitely scalable and cost-effective. We'll use their Media Convert service to transcode those files into different formats for phones, tablets, and TVs. For the user database, we'll use a managed service like RDS or DynamoDB to handle the load and take away the headache of database administration. And to handle those huge traffic spikes, we'll design an auto-scaling architecture using EC2 instances, or maybe even go serverless with AWS Lambda, to only pay for the compute time we actually use. They create the master blueprint, the diagrams that show how every single piece connects, how data flows, where the security firewalls sit, and how the entire system can heal itself if one part fails. They are playing a game of 4D chess, considering performance, security, reliability, and this is the big one, cost. And that's precisely why this role is so ridiculously in demand. A great cloud architect is a money-printing machine for a company. A bad one, or the absence of one, can be catastrophic. We've all heard the horror stories. The startup that accidentally leaves a development database open to the public, resulting in a massive data breach. Or the company that misconfigures a service and wakes up to a $100,000 cloud bill for a single month. A cloud architect prevents these nightmares. They design for cost optimization from day one, using the right services for the right job, ensuring that the company isn't paying for a V12 engine when they only need a fuel-efficient 4-cylinder. They also build for the future. They don't just solve today's problem. They look at the business roadmap and design a system that won't need to be completely ripped out and replaced in 2 years. They build in flexibility and scalability, so when the CEO comes back and says, "Great news, we're expanding to Europe and Asia next quarter," the architect can say, "No problem. The foundation we built can support that. Here's the plan." So, what's the price tag for this kind of strategic genius? It's significant. According to Glassdoor, the average salary for a cloud architect in the United States is hovering around $154,000 a year. But that's just the average. For senior architects, especially those specializing in a specific platform like AWS, Azure, or Google Cloud, or those with expertise in high-stakes fields like finance or healthcare, salaries pushing $200,000, $250,000, or even higher, plus bonuses and stock options, are absolutely the norm. Companies are willing to pay a premium for someone who can prevent million-dollar mistakes and enable billion-dollar growth. Now you might be thinking, okay, I'm sold. How do I become this master city planner of the cloud? Well, this isn't an entry-level gig. You don't just graduate and become a cloud architect. It's a role you grow into. The path usually starts with hands-on experience. You might be a software developer, a systems administrator, or a cloud engineer for several years. You get your hands dirty building the roads, the plumbing, the power grids. You learn what works and what doesn't in the real world. While you're building that experience, you start to zoom out. You stop just looking at the individual task in front of you and start asking why. Why are we using this database instead of that one? What are the security implications of this network configuration? How does this new feature we're building fit into the company's larger goals? You start thinking like an architect. Certifications are also a massive part of this journey. They are your formal education in cloud architecture. The big three are the AWS Certified Solutions Architect, both the associate and the much tougher professional level, the Microsoft Certified Azure Solutions Architect Expert, and the Google Professional Cloud Architect. Studying for these forces you to learn the breadth of the platform, not just the one or two services you use every day. It teaches you the art of the possible. But the single most important skill, the one that separates a good architect from a great one, isn't purely technical. It's communication. You have to be able to sit in a room with executives and explain a multi-million-dollar technical strategy in a way they can understand and get excited about. You have to be able to debate with engineering teams and justify your design choices. You are a leader, a negotiator, and a teacher all wrapped into one. The cloud architect is truly a pinnacle role in the tech world, blending deep technical expertise with sharp business acumen. It's about designing the future, not just implementing the present. But what if you could be even more specialized? What if, within this vast digital city, you were the one they called to design the impenetrable bank vault? The person responsible for protecting the most valuable assets from the most sophisticated threats in the world? Because while the architect designs the entire city, our number one job focuses on its single most critical aspect, an area where the demand is exploding and the salaries are reaching astronomical heights. We are talking about the guardians of the digital realm, the cyber sentinels. The number one most in-demand, highest-paying, and arguably most critical job in cloud computing right now is the cloud security engineer. Think about it. Every single company, from the hottest new startup to the most powerful Fortune 500 giant, is betting its entire future on the cloud. They are moving their most sensitive data, their proprietary algorithms, their customer information, their financial records, literally the keys to their kingdom, into these vast digital ecosystems run by Amazon, Microsoft, and Google. What is the one thing that keeps every CEO, every board member, every investor awake at night? The fear that it could all be stolen in an instant. A single breach, a single vulnerability, that's all it takes to bring a multi-billion-dollar empire to its knees. We see the headlines every single day. Massive ransomware attacks, state-sponsored espionage, data leaks that affect millions of people. The financial cost is staggering, often running into the hundreds of millions of dollars. But the reputational damage? That can be fatal. This is not a hypothetical threat. It is the brutal reality of the 21st century business landscape. And standing in the breach on the front lines of this digital war is the cloud security engineer. They are not just an IT professional. They are a company's last line of defense. They are the expert that everyone turns to when the alarms are blaring and everything is on the fire. So what does this digital warrior actually do? It's a fascinating blend of being a fortress architect, a detective, and a first responder all rolled into one. First, there's the proactive side, building the defenses. A cloud security engineer doesn't just bolt on security after the fact. No, they are involved from the very beginning, working alongside the cloud architects and DevOps engineers we've already discussed. They are the ones asking the tough questions. How are we encrypting this data, both when it's sitting still and when it's moving? Who has access to this critical system? And how are we verifying their identity? They design and implement what's called a defense in-depth strategy, creating multiple layers of security. Think of it like a medieval castle. You don't just have one big wall. You have a moat, an outer wall, an inner wall, watchtowers, and heavily guarded gates. In the cloud, this means configuring firewalls, setting up intricate identity and access management, or IAM policies, implementing intrusion detection systems, and ensuring every piece of the infrastructure is hardened against attack. They essentially build the digital fortress from the ground up, anticipating the enemy's moves before they are ever made. But no fortress is truly impenetrable. That's where the second part of their job comes in: threat hunting and incident response. This is the adrenaline-fueled, high-stakes part of the role. Cloud security engineers are constantly monitoring the environment, using sophisticated tools called SIEMs, security information and event management systems, to look for anomalies, for the faint digital footprints of an intruder. They are digital detectives, piecing together clues from logs and network traffic to uncover a hidden threat. And when an attack does happen, and it will happen, they are the digital firefighters. They spring into action to contain the breach, to isolate the affected systems, to kick the attacker out, and to understand exactly how they got in so they can patch the vulnerability and prevent it from ever happening again. This is a high-pressure, high-impact role where your actions in a matter of minutes can save a company from catastrophic failure. Finally, there's the third pillar: compliance and governance. This might sound less glamorous, but it is a massive driver of demand for these roles. Companies in industries like healthcare, finance, and government have to adhere to incredibly strict regulations like HIPAA for patient data or PCI DSS for credit card information. A cloud security engineer is the expert who ensures the company's cloud environment meets these stringent standards. They conduct audits, automate compliance checks, and generate the reports that prove to regulators that the company is a responsible steward of its sensitive data. Failing a compliance audit can result in crippling fines and a total loss of customer trust, making this function absolutely mission-critical. So, what does it take to become one of these elite digital defenders? The path is demanding, but the rewards are immense. First and foremost, you need a rock-solid foundation in IT and cybersecurity fundamentals. We're talking networking, understanding how data flows across the internet. We're talking operating systems, knowing the guts of Linux and Windows. And of course, you need a deep understanding of core security concepts like cryptography, vulnerability management, and the common tactics used by hackers. On top of that, you must become an expert in at least one of the major cloud platforms, AWS, Azure, or GCP. You can't secure what you don't understand. You need to know their services inside and out, especially their security-specific tools. For AWS, that means mastering services like IAM, Security Hub, GuardDuty, and KMS. For Azure, it's Sentinel, Microsoft Defender for Cloud, and Azure Active Directory. But the real differentiator, the thing that separates a good cloud security engineer from a great one, is having a hacker mindset. You have to learn to think like your adversary. You have to constantly be asking, if I wanted to break into this system, how would I do it? This is why many of the best security professionals have backgrounds in ethical hacking or penetration testing. They understand the attacker's playbook, which allows them to build more resilient defenses. Now let's talk about the reason this job sits at the very top of our list: the salary. The demand for skilled cloud security professionals has created a massive talent shortage, and companies are willing to pay an extraordinary premium to hire and retain them. According to recent data from job sites and industry surveys, an experienced cloud security engineer in the United States can expect a base salary ranging from $150,000 to well over $200,000 a year. Senior-level professionals, or those who specialize in niche areas, can easily command salaries of $225,000, $250,000, or even more. And when you factor in bonuses, stock options, and other benefits, the total compensation can be truly astronomical. Why is the pay so high? It's simple economics. The cost of a single major data breach can easily exceed $100 million. When you look at it that way, paying a security expert $250,000 a year isn't an expense. It's one of the best investments a company can possibly make. You are not just hiring an employee. You are buying insurance against a corporate apocalypse. And the future? It's brighter than any other role in tech. As we connect more devices to the internet through the Internet of Things, as artificial intelligence is used to launch more sophisticated cyber attacks, and as every last bit of data on the planet migrates to the cloud, the attack surface for companies is expanding exponentially. The need for savvy, skilled, and vigilant cloud security engineers will not just continue. It will accelerate at a breakneck pace. This isn't just a job. It's a career that offers a decade or more of guaranteed relevance, constant learning, and the opportunity to do work that genuinely matters. You are protecting people's data, you are defending critical infrastructure, and you are enabling the very innovation that drives our modern world. And that is why the cloud security engineer is, without a doubt, the #1 cloud computing job in America right now. So now you have the list. The top 5 most in-demand, highest-paying, and future-proof cloud computing jobs in the United States. We've covered everything from the DevOps engineer who builds the automated highways of the cloud, to the cloud architect who designs the city itself, all the way to our #1 spot, the cloud security engineer, the guardian who protects it all. But a list is just a list. It's a map without a compass. It shows you the destination, that 6-figure salary, that fulfilling career, that seat at the table where the future is being built. But it doesn't tell you how to start the journey. And that's the question that really matters, isn't it? Okay, great. Now what? How do you go from where you are right now, whether you're a student, a career switcher, or an IT pro looking to level up, to actually landing one of these elite roles? This is where the real work begins. And it's where most people get it wrong. They jump straight to the advanced, shiny tools. They try to learn Kubernetes before they understand networking. They chase an advanced security certification before they can even explain the difference between a stateful and a stateless firewall. It's like trying to build a skyscraper without laying a foundation. The first strong wind, the first tough interview question, and the whole thing comes crashing down. We're not going to do that. We're going to build your career the right way, from the ground up with a foundation of solid steel. I'm going to give you the exact step-by-step roadmap, and it starts with what I call the foundational trinity. These are the 3 non-negotiable pillars of knowledge you must have before you even seriously think about the cloud. The first pillar is networking. I want you to forget about the cloud for 1 second and picture a major city. What's the most critical piece of infrastructure? It's not the tall buildings. It's the roads, the highways, the subway tunnels. It's the system that allows people and goods to move from one place to another. Without it, the city grinds to a halt. In the digital world, that's networking. It is the road system for data. You absolutely must understand how data travels from point A to point B. This means understanding the TCP/IP model, knowing what DNS is and why it's the phone book of the internet, and understanding how protocols like HTTP and HTTPS work. In the cloud, this knowledge translates directly to concepts like virtual private clouds, or VPCs, subnets, and routing tables. If you don't understand how these digital roads work, you'll never be able to build secure, efficient, and resilient applications. It is the absolute bedrock. The second pillar of the foundational trinity is operating systems, and specifically Linux. I'll say it plainly. If you want a serious career in cloud computing, you need to be comfortable on the Linux command line. Why? Because the cloud runs on Linux. The vast majority of servers on Amazon Web Services, Google Cloud, and Microsoft Azure are running some flavor of Linux. It is the engine of the internet. You don't need to be a kernel developer, but you need to be able to navigate the file system, manage permissions, install software, and read log files, all from that black screen with the blinking cursor. It's about fluency. When you can move around in a Linux environment without thinking, you've unlocked a core competency that every single one of our top 5 jobs requires. The third and final pillar is security fundamentals. Notice I didn't say cloud security, just security. This goes back to first principles. You need to internalize what we call the CIA triad: confidentiality, integrity, and availability. Confidentiality means keeping data secret from those who shouldn't see it. Integrity means ensuring the data hasn't been tampered with. And availability means making sure the systems are up and running when they're needed. Every single security tool, every compliance framework, every best practice in the cloud is designed to serve one or more of these 3 principles. When you understand this triad at a gut level, you stop just following a checklist and you start thinking like a security professional. You start asking the right questions. Okay, so you've got your foundation. You understand networking, you're comfortable in Linux, and you get the core principles of security. Now, and only now, are you ready to choose your cloud. And you've got the big 3 Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, GCP. Here's the most important piece of advice I can give you at this stage. Pick one. Just one. Do not try to learn all 3 at once. That is the fastest path to burnout and knowing a little bit about everything but not enough about anything to get hired. The good news is that the core concepts are transferable. A virtual machine is a virtual machine, whether AWS calls it an EC2 instance, Azure calls it a virtual machine, or GCP calls it a compute engine instance. The underlying principles you learned in your foundational studies are the same. You're just learning the specific dialect of one platform. So which one do you pick? AWS is the market leader. It was the first to the game and has the biggest market share. This means there are more jobs that list AWS skills, and there's a massive community and a treasure trove of tutorials and documentation. For many, it's the default starting point. Microsoft Azure is the enterprise giant. It is incredibly strong in large corporations, especially those that already have a deep investment in Microsoft products like Windows Server, Office 365, and Active Directory. If you're targeting a job at a Fortune 500 company, knowing Azure is a powerful advantage. Google Cloud Platform, or GCP, is often seen as the innovator, with incredible strengths in areas like data analytics, machine learning, and especially containers and Kubernetes, which Google originally developed. Startups and tech-forward companies often lean heavily on GCP for its cutting-edge services. My advice? Look at the job descriptions for the roles you want, in the cities you want to live in. See which platform appears most often. For most people, that's going to be AWS. But if you see a heavy concentration of Azure, that's your signal. Don't overthink it. Just pick one and go deep. Once you've picked your platform, the next step is certifications. Now this is a hot debate online. You'll see people screaming that certifications are useless paper, and only hands-on experience matters. You'll see others who say you can't get a job without them. The truth, as always, is somewhere in the middle. Here's how you should think about it. A certification is not a golden ticket that guarantees you a job, but it is two very important things. First, it's a structured learning path. It gives you a curriculum and forces you to learn the core services of a platform in a logical order. Second, it's a signal. It's a verifiable credential that tells a recruiter or a hiring manager, who might be sifting through hundreds of resumes, that you have at least a baseline level of knowledge and that you are serious enough to have invested the time to study and pass a proctored exam. Gets your foot in the door. For each platform, there's a clear starting point. For AWS, start with the AWS Certified Cloud Practitioner. This is the foundational level. Once you pass that, the real prize is the AWS Certified Solutions Architect Associate. This is arguably the most recognized and respected entry to mid-level cloud certification in the world. For Azure, you'll start with the AZ900, Azure Fundamentals, and then move on to the AZ104, Microsoft Azure Administrator Associate. For GCP, you begin with the Cloud Digital Leader and then target the Associate Cloud Engineer. Your goal isn't just to pass the test. Your goal is to absorb the knowledge. When you're studying, for every service you learn about, you should be spinning it up in the free tier of your chosen cloud provider. This brings us to the most critical step of all, the one that ties everything together and actually makes you hireable: hands-on projects. Theory will get you past a phone screen. Hands-on, project-based experience is what will get you the job offer. You have to build things. You have to break things and then figure out how to fix them. This is where the learning really happens. Don't just follow a tutorial click for click. Do the tutorial but then change it. Add a new feature. Try to secure it. Try to automate it. Start simple. A fantastic first project is to deploy a basic 3-tier web application. This means you have a web server for the front end, an application server for the business logic, and a database for the back end, all running on separate virtual machines inside your own custom-built virtual private cloud. Make them talk to each other, but make sure they're locked down from the public internet. Just building this one project will teach you more than 100 hours of video lectures. Then you level it up. Want to be a DevOps engineer? Take that same project and learn how to write it as code using a tool like Terraform so you can destroy and recreate the entire environment with a single command. Then, build a CI/CD pipeline using GitHub Actions or Jenkins to automatically deploy new code to your application whenever you make a change. Want to be a cloud security engineer? Take that same project and run a vulnerability scanner against it. Implement proper firewall rules. Set up logging and monitoring to send you an alert if someone tries to SSH into your web server from an unauthorized IP address. You document every single one of these projects on your GitHub profile. You write a short blog post about what you built and what you learned. This becomes your portfolio. This is your proof. When you walk into an interview and they ask you about your experience, you don't just say, "I studied for a certification." You say, "Let me tell you about the time I built a scalable, secure, and automated web application from scratch in AWS." That is the conversation that gets you hired. This roadmap, foundation, platform, certification, and projects is the system. It works. But there's another layer to this. There are specific high-level skills that cut across all of these roles, skills that separate the $100,000 a year engineer from the $300,000 a year architect. These are the force multipliers, the skills that, once you acquire them, make you an indispensable asset to any company you join. And that's exactly what we're going to break down next. The first force multiplier, the one that separates the 6-figure pros from the 7-figure legends, is mastering the art of the digital fortress. I'm talking about deep, intricate, unshakable knowledge of networking and security. Now I know what you're thinking. Networking? Security? Isn't that boring? Isn't that what the security team handles? No, that's the thinking that keeps you stuck. The world's best cloud architects and DevOps engineers don't just use the cloud. They build the very ground it stands on. They understand that a virtual private cloud, a VPC, isn't just a container for your servers. It's a strategic blueprint. It's a digital kingdom with carefully designed borders, checkpoints, and secret passages. They can architect a multi-tiered network with public subnets for web servers that need to greet the world, and private subnets, locked away in the darkness, for the databases holding the crown jewels. They don't just click allow all traffic on a security group. That's amateur hour. They craft firewall rules with the precision of a surgeon, allowing only specific traffic on a specific port from a specific source. They understand the difference between a stateful security group and a stateless network access control list. And they know exactly when to use each one to build layers of defense, like the concentric walls of a medieval castle. They treat identity and access management, or IAM, not as a chore, but as their primary weapon. They live and breathe the principle of least privilege, ensuring that every user, every service, every single line of code has the absolute minimum level of access it needs to function, and not announce more. Why? Because every unnecessary permission is a potential backdoor for an attacker. Think about it this way: anyone can follow a tutorial to launch a virtual server. That's like learning to lay a single brick. A true architect, a $300,000 a year architect, is the one who can design the entire fortress. They understand the load-bearing walls, the plumbing, the electrical, and most importantly, how to make it impenetrable. When you can walk into an interview and not just talk about servers, but about designing a multi-region, disaster-proof, HIPAA-compliant network architecture from the ground up, you're not having a conversation about a job anymore. You're having a conversation about how much they're going to pay you to be the guardian of their entire digital existence. That is power. The second force multiplier is the closest thing we have to a superpower in the tech world: infrastructure as code and extreme automation. This is the skill that allows one person to do the work of 100. Let me paint you a picture. Company A has a team of 10 engineers who manually configure their servers. They click through the web console, they type commands into a terminal, and when they need to launch a new environment for a big client, it takes them 2 weeks of careful, nerve-wracking work. Every single time there's a risk of human error. A forgotten setting, a typo in a configuration file, that could bring the whole system crashing down. Now look at Company B. They have one engineer. We'll call her Sarah. Sarah doesn't click buttons. She writes code. She uses tools like Terraform or CloudFormation to define her entire infrastructure: the servers, the databases, the networks, the firewalls, in simple, readable text files. Her infrastructure isn't a fragile, hand-built sculpture. It's a recipe, a blueprint. When Company B needs a new environment, Sarah doesn't spend 2 weeks stressed out. She runs a single command: Terraform apply. She goes for a coffee, and 15 minutes later, a perfect, identical, error-free copy of their entire production environment is up and running. If a server crashes, she doesn't panic. She lets the automation handle it. If they need to scale from 10 servers to 1,000 to handle a massive traffic spike from a Super Bowl ad, she changes one number in a text file and runs the command again. This is not just about convenience. This is a fundamental shift in how technology is built. Infrastructure as code makes your systems repeatable, testable, and disposable. It eliminates configuration drift and makes catastrophic human error a thing of the past. When you master a tool like Terraform, you stop being an administrator who babysits servers. You become a commander who marshals entire armies of resources with a single command. You are the one who can tell the chief technology officer, yes, we can deploy our entire application in a new country, on a new continent, in under an hour. The person who can do that isn't just a valuable employee. They are a strategic weapon. They are the leverage that allows a small startup to compete with a global enterprise. And that kind of leverage comes with a very, very big paycheck. Next up, the third force multiplier, and this one will make you a hero to every executive, every manager, and every shareholder in the company. It's the mastery of cloud cost optimization, or what the industry is now calling FinOps, financial operations. In the early days of the cloud, the goal was just to get things working. Move to the cloud. It's amazing. And it was. But then the bills started coming in, and they were massive. Companies were suddenly spending millions, sometimes tens of millions of dollars a year, and they had no idea if they were spending it wisely. This created a huge demand for a new kind of expert, the cloud economist. The person who understands not just the technology but the business of the cloud. This isn't about being cheap. It's about being ruthlessly efficient. A regular engineer can launch a powerful server. A cost optimization expert knows that by using a fleet of smaller, cheaper spot instances that are 90% cheaper, combined with a few reserved instances for baseline load, they can achieve the same performance for a fraction of the price. A regular developer might store terabytes of data in a standard storage class. The FinOps master knows to implement lifecycle policies that automatically move that data to cheaper, archival storage tiers after 90 days, saving the company thousands of dollars every single month automatically. They are masters of tagging, ensuring every single resource is labeled with the project, team, and cost center it belongs to, so there are no more mystery charges on the bill. They use tools like the AWS Cost Explorer or Azure Cost Management to hunt down waste. Zombie servers that are running but doing nothing, oversized databases that are barely being used, unattached storage volumes that are just sitting there, burning money. Being able to go to your boss and say, "I just saved our department $200,000 this year by re-architecting our data storage strategy," is one of the most powerful career moves you can ever make. It translates your technical skills directly into the language of business, profit and loss. You stop being a cost center and become a profit driver. And when it's time for promotions and raises, the person who is actively making the company more profitable is always first in line. The final force multiplier is about skating to where the puck is going. It's about moving beyond just managing infrastructure and starting to build intelligence. I'm talking about developing a deep expertise in advanced data, machine learning, and AI services. Look, knowing how to manage virtual servers and databases is the baseline now. It's table stakes for getting a job. But the companies that are going to dominate the next decade are the ones that can turn their mountains of data into actionable insights and predictive models. This means going beyond the basics. It's not just about knowing what a database is. It's about understanding when to use a high-speed in-memory database like Redis for caching, a petabyte-scale data warehouse like BigQuery or Redshift for analytics, or a NoSQL database like DynamoDB for massive-scale applications. It's about knowing how to build data pipelines that ingest, clean, and process information in real time. But the real game changer is machine learning. The top cloud platforms, AWS, Azure, and Google Cloud, are no longer just infrastructure providers. They are AI powerhouses. They offer incredible services like Amazon SageMaker, Azure Machine Learning, and Google's Vertex AI that allow companies to build, train, and deploy sophisticated machine learning models without needing a whole army of PhDs. The cloud professionals who are commanding the absolute highest salaries are the ones who can bridge the gap between infrastructure and data science. They are the ones who can help a retail company build a real-time recommendation engine. They can help a bank build a fraud detection model that saves millions in losses. They can help a healthcare provider use image recognition to spot diseases earlier and more accurately. When you can do that, you are no longer just keeping the lights on. You are creating the future of the business. You are building the crystal ball that allows the company to see what's coming and make smarter decisions than its competitors. This is the absolute cutting edge, and it's where you'll find the most exciting, the most impactful, and the most lucrative opportunities in the entire cloud computing landscape. So now you know the jobs that are in white-hot demand, and you know the elite, force-multiplying skills that separate the high earners from the absolute top tier of the industry. You have the map to the treasure. But there's one final, crucial piece of the puzzle. It's one thing to learn about these skills, to read the documentation and watch the tutorials. It's another thing entirely to prove to a hiring manager, to a skeptical interviewer, that you can actually do it. How do you build the kind of killer portfolio and hands-on projects that make you an irresistible hire, even if you don't have years of on-the-job experience yet? How do you demonstrate your value before you even get the offer? That's the bridge we need to cross, and it's exactly what we're building in the next section. So let's build that bridge. The foundation isn't your resume. The steel beams aren't your certifications. Those are just the blueprints. The bridge itself, the thing that will actually carry you from aspiring cloud professional to hired cloud professional, is your portfolio. But I'm not talking about a dusty GitHub profile with a few half-finished tutorial projects. I'm talking about a living, breathing testament to your skills, a weapon designed to dismantle doubt in a hiring manager's mind. This is about building a proof-of-work portfolio. It's a strategic collection of projects and documentation that doesn't just say what you know, it proves what you can do. It answers the silent question every interviewer has. Can this person actually solve my company's problems and make us money? Forget everything you think you know about portfolios. This isn't a scrapbook. It's a sales pitch. And you are the product. We're going to structure this around 3 core pillars. Get these 3 right and your portfolio will do the talking for you. Pillar number 1 is what I call the real-world replica project. This is the absolute cornerstone. The biggest mistake people make is following a YouTube tutorial step-by-step, building the exact same to-do list app as 10,000 other people, and calling it a day. That doesn't prove you can solve problems. It proves you can follow instructions. Instead, you need to find a problem, a real one, and solve it with the cloud. Think small but think real. You don't need to build the next Netflix. Does your cousin run a small bakery and need a simple, scalable website with an online order form? That's a project. Don't just build the website. Host it on AWS S3 for static content. Use API Gateway and Lambda functions to process the orders, and store the order data in DynamoDB. Now you're not just a web developer. You're a cloud engineer who understands serverless architecture, cost-effective hosting, and database management. Document every single decision. Why S3 instead of an EC2 instance? Because it's cheaper and scales infinitely for static assets. Why Lambda? Because you only pay for the milliseconds the code is running, which is perfect for a small business with unpredictable order volume. You've just demonstrated technical skill and business acumen. Or let's say you're targeting a DevOps role. Take that same bakery project and build a complete CI/CD pipeline for it. Use GitHub Actions to automatically trigger a build and test sequence every time you push new code. If the tests pass, have the pipeline automatically deploy the new version to your S3 bucket and update the Lambda functions. You've just shown you can automate the entire software delivery lifecycle. You've proven you understand the core principles of DevOps, reducing manual error, increasing deployment frequency, and creating a reliable, repeatable process. This is 1,000 times more powerful than a certification that says you know what CI/CD stands for. For the aspiring cloud security engineers, your angle is different. Take one of these projects, either your own or a popular open source one, and put on your white hat. Your project is to secure it. Create a detailed report. First, implement proper identity and access management. Create IAM roles with the absolute least privilege necessary for the Lambda functions to access DynamoDB. No wildcard permissions. Then configure the network. Set up tight security groups and network ACLs. Maybe even run a vulnerability scanner like Amazon Inspector against the environment and document your findings. You can then write a summary of the vulnerabilities you found and, more importantly, how you fixed them. This shows a proactive, security-first mindset that is desperately needed in the industry. You're not just someone who read about security best practices. You're someone who implements them. That's Pillar 1. Build something that solves a real, tangible problem. But don't stop there. Pillar number 2 is the cost optimization case study. This is your secret weapon, because it speaks the one language every single business on the planet understands. Money. The cloud is powerful, but it can get expensive fast. Showing you know how to control and reduce that cost makes you exponentially more valuable. Here's how you do it. Take your real-world replica project and document its initial architecture and estimated monthly cost. Use the AWS pricing calculator or the Azure equivalent. Be detailed. Now, your second project is to re-architect that same application for maximum cost savings. Maybe in version 1, you used AT3.micro EC2 instance to run a small part of the application. In version 2, you refactor it to run on a Graviton-based ARM instance, which offers a better price-to-performance ratio, and you write a paragraph explaining why you made that switch and the percentage you saved. Maybe you were storing user-uploaded images in a standard S3 storage class. In version 2, you implement an S3 lifecycle policy to automatically move images that haven't been accessed in 30 days to the infrequent access tier, and after 90 days to Glacier Deep Archive. Then, you create a beautiful, simple case study. A single page in your GitHub README will do. Version 1 architecture. Estimated cost $15 per month. Version 2 architecture. Estimated cost $4 per month. Savings, 73%. Then you explain how you achieve those savings. This is a jaw-droppingly effective technique. You are literally showing a hiring manager, if you hire me, I will save you money. You're no longer just a cost center, an expense on a spreadsheet. You are an investment with a clear return. Now for the final piece that ties it all together. Pillar number 3, the teach and document method. It's not enough to build great things. You have to prove you can communicate how and why you built them. This is the skill that separates junior engineers from senior architects. The best way to do this is to teach what you've learned. Start a blog on a platform like Medium or Hashnode. For every significant project you build, write a detailed article about it. Don't just post the code. Explain your thought process. I chose DynamoDB over RDS for this project because the access patterns were simple key-value lookups, and the serverless nature of DynamoDB aligned with my goal of minimizing operational overhead. That single sentence reveals a huge amount about your understanding of cloud-native design principles. Create video walkthroughs. You don't need a fancy studio. A simple screen recording using OBS where you walk through your project's architecture diagram and explain the data flow is incredibly powerful. Post it on LinkedIn. Post it on YouTube. This demonstrates your communication skills in a way a resume never can. Contribute to the community. Find a tool you used in your project and contribute to its documentation on GitHub. Answer questions on Stack Overflow or Reddit about services you're familiar with. This creates a public record of you being a helpful, knowledgeable expert. When you combine these three pillars, your portfolio becomes an unstoppable force. You have a real-world replica project that proves your technical skills. You have a cost optimization case study that proves your business value. And you have your blog posts, videos, and community contributions that prove your communication skills and your passion. This isn't just a list of projects anymore. It's a narrative. It tells the story of a proactive problem solver who understands technology, business, and communication. It's the bridge that closes the gap between your current skills and the job you want. You are no longer just another applicant with a certification. You are a proven asset. So you've built the skills. You've built the proof of work portfolio that screams value. You've built the bridge. Now all that's left is to walk across it. How do you take this incredible arsenal you've assembled and use it to absolutely crush the technical interview? How do you articulate your project's value under pressure and turn that final conversation into a job offer? That's the final step, and it's where we're going next. You've walked through the fire. You've mastered the core services, you've battled through the certifications, and you've built a project that isn't just a line on a resume. It's a living, breathing testament to your skills. Now you're standing at the final gate. The technical interview. This isn't just a test. Forget that idea right now. This is a conversation. It's a collaborative problem-solving session with your potential future colleagues. They aren't there to watch you fail. They're desperately hoping you're the one who can solve their problems. Your job is to make it easy for them to say yes. Let's start by rewiring your brain about the entire process. The single biggest mistake candidates make is walking in with a student taking a test mentality. You are not there to regurgitate facts. You are there as a professional consultant, brought in to diagnose a problem and propose a solution. You are interviewing them just as much as they are interviewing you. This shift in mindset from "please give me a job" to "let's see if we can solve valuable problems together" is the foundation of a winning performance. So how do you do it? We break it down into three arenas where you'll be tested: the story, the system, and the code. First, the story. These are the so-called behavioral questions. They almost always start with "tell me about a time when." Don't you dare dismiss these as soft skills fluff. This is where they decide if they want to work with you for 40 hours a week. They're testing your thought process, your ownership, and your ability to communicate complex ideas. And you have the perfect weapon, your project. You need to master the STAR method: situation, task, action, result. But let's call it what it really is: hero, mission, battle, victory. When they ask, "Tell me about a challenging technical problem you solved," don't just say, "I had to fix a bug." No, you tell a story. The hero is you. The situation is the context. We were building a serverless image processing pipeline to automatically generate thumbnails for user-uploaded content. The mission or the task was the specific goal. The initial design was slow and expensive, taking over 30 seconds per image and running up a huge bill because it wasn't optimized. The battle is your action. This is the core of your answer. Walk them through your thought process step by step. First, I used CloudWatch logs to identify the bottleneck. I discovered the Lambda function was configured with minimal memory, which also limited its CPU power. I also noticed it was downloading the full, high-resolution image every single time. So I took a two-pronged approach. I increased the function's memory allocation, which immediately cut processing time in half. Then I re-architected the S3 trigger to first generate a pre-signed URL, passing that to a separate optimized Lambda function that used a library like sharp.js to resize the image stream directly, without saving the full file to disk. And finally, the victory. The result. Quantify it. As a result, we reduced the average processing time from 30 seconds to under 3 seconds, a 90% improvement. This also led to a 75% reduction in our monthly Lambda and data transfer costs, directly impacting the project's profitability and improving the user experience. See the difference? You didn't just fix a bug. You were a detective, an architect, and a business-savvy engineer. You used the tools, diagnosed the problem, architected a solution, and delivered measurable value. Every single project you built has at least 5 of these stories buried inside it. Your mission is to excavate them and polish them until they shine. Next up, the main event for many cloud roles, the system. This is the system design interview. You'll be given a vague prompt, like design a photo sharing app like Instagram, or design a URL shortening service. The number one mistake? Jumping straight into solutions. The interviewer isn't looking for the right answer. There is no single right answer. They're buying a ticket to watch your brain work. Your first job is to be the world's best detective. Ask clarifying questions for at least 5 minutes. How many users are we expecting? 1,000? A billion? What's the ratio of reads to writes? Are we designing for a global audience? What are the key features for V1? Just photo uploads in a feed? Or do we need comments, likes, and direct messaging? What are our constraints? Are we optimizing for low latency, high availability, or low cost? By asking these questions, you're not just stalling. You're demonstrating that you don't make assumptions. You define the problem before you try to solve it, a hallmark of a senior engineer. Once you've narrowed the scope, sketch out a high-level V1 architecture on the whiteboard. Think big boxes and arrows. Okay, so we'll have users upload to a web server. We can put these servers in an auto-scaling group behind an elastic load balancer for high availability. The images themselves won't be stored on the servers. We'll upload them directly to an S3 bucket. This triggers a Lambda function for thumbnailing like in my project. The metadata, like the username and image URL, gets written to a database. For this scale, maybe a managed NoSQL database like DynamoDB would be a good fit because of its scalability and key value access patterns. Now you start the deep dive. This is where you connect the boxes. The interviewer will poke and prod. What happens if DynamoDB goes down in one region? And you respond, that's a great point. For V2, we'd enable DynamoDB global tables to replicate our data across multiple regions, providing both disaster recovery and lower latency for our global users. How would you deliver the images quickly to users in Asia? We'd put Amazon CloudFront, our CDN, in front of the S3 bucket. This would cache the images at edge locations around the world, drastically reducing latency. The magic words in a system design interview are trade-offs, and it depends. Always be discussing trade-offs. We could use a relational database like RDS, which gives us strong consistency, but DynamoDB gives us better horizontal scalability, which seems more important for a social media feed. It depends on our consistency requirements. This shows maturity. It shows you know there's no perfect solution, only the best solution for a given set of constraints. Finally, we have the code. This could be a live coding challenge, a troubleshooting scenario, or a script writing task. The goal here is not to write flawless production-ready code in 20 minutes. The goal is to communicate your thought process. Think out loud. Say you're asked to write a Python script to find duplicate files in an S3 bucket. Start by verbalizing your plan. Okay, my approach would be to iterate through all the objects in the bucket. For each object, I'll need to calculate a hash, probably an MD5 hash of the file's contents. I'll store these hashes in a dictionary or a hash map, where the key is the hash and the value is a list of file paths that have that hash. If I encounter a hash that's already in my map, I know I've found a duplicate. I'll just append the new file path to the list. Finally, I'll iterate through my map and print out any entries that have more than one file path. As you write the code, explain what you're doing. Okay, I'm importing the Boto3 library here to interact with the S3 API. Now I'm creating the S3 client. I'll need to handle pagination for buckets with more than 1,000 objects. So I'll use a paginator here to make sure I get every single file. If you get stuck, say so. I'm blanking on the exact syntax for the S3 paginator. Let me quickly think. I believe it's client _ paginator. List _ objects _ v2. I'd normally double check this in the documentation to be certain, but I'm pretty confident that's the right direction. This shows honesty and a solid process, which is infinitely more valuable than pretending you've memorized every API call. And when the interview is winding down, you get to ask the questions. Do not waste this opportunity by asking about vacation days. This is your final chance to prove you are a top-tier candidate. Ask insightful, challenging questions. Ask, what does the on-call rotation look like? And what's the team's philosophy on postmortems and blameless retrospectives? This shows you care about operational excellence. Ask, can you walk me through the path of a line of code, from a developer's laptop to production? What are the stages of testing and deployment? This shows you care about quality and process. My favorite, what is the biggest technical debt the team is currently facing, and what is the plan to address it? This demonstrates courage and shows you're already thinking about how you can contribute. You've done the work. You have the skills. The project is your proof. The interview is simply your stage to tell its story, to showcase your thought process. To prove that you aren't just a candidate looking for a job, you are the solution they've been looking for. This entire journey, from the first video in this series to this very moment, has been about forging you into that solution. The cloud is not some distant, abstract thing. It is a world of opportunity built on a foundation of tangible skills you now possess. The only thing left to do is to go out there and claim your place in it. The future you want isn't going to be given to you. It's something you have to build, one API call, one commit, one successful interview at a time. The cloud isn't just the future of technology, it's your future. Go build it.